Hi class, in this recording we're going to focus on blood flow through the heart, and we're going to focus on how blood is pumped through the heart. I need to emphasize for you that the two ventricles contract at the same time and relax at the same time. So what one chamber is doing, the other chamber will do. If one atria is contracting, the other atria contract. If one ventricle is relaxing, the other ventricle will relax. And as ventricles are relaxing, those ventricles typically are going to experience a pressure drop. And that pressure drop inside of the ventricle is going to cause blood to flow just ever so slightly backwards through the artery and pulmonary aorta. And as it flows backwards just a little tiny bit, it causes the semilunar valves, the pulmonary semilunar and the aortic semilunar valves, to snap shut. And then, as we have that low pressure inside of the ventricles, the AV valves will pop open and blood flows into the ventricles from the atria. When the ventricles are contracting, the AV valves are slapped shut or snapped shut because blood tries to flow backwards up into the atria first, and then once those AV valves snap shut, pressure begins to build in the ventricles, and eventually the pressure becomes so great that the pulmonary semilunar valves and the aortic semilunar valves are going to be popped open, and blood will leave the heart through those major arteries. We're going to camp on this slide for a long time. This is a very important slide. Class, you need to commit this slide to memory. I'm going to get a little preachy right here. You need to know this off the top of your head as a future healthcare provider. If you do not know the path of blood flow through the heart as a healthcare provider, you are going to scare your patients. This needs to be tacit knowledge. I remember when I was in 6th grade and I had to memorize this. My 6th grade teacher, Mrs. Thompson, took a bunch of masking tape and made a masking tape heart on the classroom floor. And then we as the students had to march around and through the heart and say the names of the structure of the heart while we were marching through the heart. And it worked. It really stuck with us. I recommend you do that if you're having trouble memorizing this. So we're going to start here at our right atria. And as blood is entering the right atria, blood will go from the right atria to flow past the right AV valve. Once that blood flows past the right AV valve, it enters the right ventricle. From the right ventricle, blood will flow past the pulmonary valve or pulmonary semilunar valve to the pulmonary trunk artery. And then from the pulmonary trunk, it's going to travel to the pulmonary branches and head to the left and right lungs. At the left and right lungs, the blood gets rid of carbon dioxide and receives oxygen. And then oxygenated blood from the left lung and the right lung will flow back towards the heart through the pulmonary veins, the left and right pulmonary veins. Remember, veins go towards the heart, arteries go away from the heart. And the pulmonary veins drain blood into the left atria or atrium. From the left atrium, blood will flow past the left atrioventricular valve into the left ventricle. From our left ventricle, blood will flow past the the aortic valve, which is hard to see, and then up into the aorta. We have the ascending aorta, which is very short and very short. It's the part of the aorta that goes up, the ascending aorta. And then we go to the aortic arch, where it arches over. And as the blood is going through the ascending aorta to the aortic arch, it's going to be distributed to the body through some major arteries that branch off of the aorta. Eventually, that blood is going to go to some capillary beds in the systemic circuit, lose its oxygen, pick up carbon dioxide, and then become deoxygenated and work its way back to the heart through increasingly large veins until it gets to the superior vena cava and the inferior vena cava, which will take that blood and dump it back into the right atrium. And this process will just continue itself over and over and over again. It's a cyclical process. Now, as we're looking at the heart, it's also important to recognize that the heart is made of living tissue. And because it's made of living tissue, it needs to stay alive. It needs nutrient exchange. 5% of the blood that exits the heart is going to immediately be rediverted to go back to the heart for coronary circulation. So the coronary circuit is a subcircuit of the systemic circuit. And this coronary circuit is going to supply blood to the cardiomyocytes, the heart tissue itself, to keep the heart alive. The heart needs about 250 milliliters of blood per minute when we are being sedentary or at rest. And if we're working really hard and we're exercising a lot, that value of blood increases. The heart is a little, it's a little selfish. The heart is not a very altruistic organ. The very first thing, the very first branches coming off of the heart, off of that ascending aorta, are coronary arteries. The right and left coronary arteries are the first branches off of the aorta, and they are going to supply blood to the heart. These major blood vessels are eventually going to go to capillary beds of the heart and supply to have nutrient exchange with the cardiomyocytes, and then form veins that carry blood back to the heart. And those veins will eventually drain the blood into the right atria of the heart. Every once in a while, something doesn't work with the heart. And I should say, not every once in a while. In the United States in particular, we have about 650, actually it's probably closer to 700,000 cardiovascular-related deaths every year. So the better part of about 1 million people die in the United States every single year from some kind of a cardiovascular incident. A very common cardiovascular incident is a heart attack. And when we talk about heart attacks, they are also known as a myocardial infarction. An infarction is a technical term that means tissue death due to lack of blood flow. What tissue is dying? The myocardium, the heart muscle tissue, is dying from a lack of blood flow to that tissue. So that's literally what myocardial infarction means. Most people, since they're so common, in healthcare, the abbreviation for that is just an MI. Laymen refer to it as a heart attack as opposed to a myocardial infarction. Leading up to the myocardial infarction, though, I jumped ahead here. We have angina pectoris. And I will frequently mispronounce this and say pectoralis, even though it's spelled pectoris. And I'm sorry if I mispronounce it. I learned to say it the wrong way, and old habits die hard. So when we have angina, angina just refers to pain. Where's this particular pain? This pain is going to be near the pectoral region. So pain due to reduced blood flow is angina, and then this pain is going to be located around the pectoral muscles. It's typically going to be on the left pectoral region of the body. And as we have reduced blood flow or ischemia of the cardiac muscle tissue, we're going to have pain build up. This obstruction is going to cause the heart muscle tissue to shift to anaerobic respiration, where instead of making 32 to 34 ATP for every glucose molecule, that they're only going to have a net yield of 2 ATP per glucose molecule. So they can those cardiomyocytes can limp along a little bit while doing this, but it's not a long-term survival strategy for those cardiomyocytes. And those cardiomyocytes are going to produce a lot of lactate as a byproduct of anaerobic respiration, and that lactate or acid will stimulate pain within the heart. To give you an idea of just how common heart attacks are for killing people, over 1/4 of all deaths in the United States, we'll just say about 1/4 of everyone who dies in the United States dies from a heart attack. So to think back to 2 slides ago, you need to know blood flow through the heart stone cold, because most of the patients you're going to die or work with either will die or know somebody who's died from a heart attack. That's all we have for this presentation. If you have any questions or comments about blood flow through the heart, please feel free to post them on the class discussion boards or to shoot me an email. And as always, happy studies.